In this video, I wanted to talk about the fundamental counting principle and mathematical permutations, combinations, and the formulas for them. And how I like to focus on them is not on the formulas, but more on the sensibility of why, and then kind of use that as a basis for understanding how do I know when I want to use a formula for a permutation versus that of a combination. And I also want to show you how you can do these calculations in your calculator as well. But it all kind of starts with a simple idea called the fundamental counting principle, which I think will make a lot more sense out of why a lot of these other formulas work. But I'll go ahead and read this principle for you. But it says, in a case where two acts can be performed, if Act 1 can be performed in m ways, and Act 2 can be performed in n ways, no matter how Act 1 turns out, then the sequence of Act 1 then Act 2 can be performed in a total of m times n ways. This is referred to as the fundamental counting principle view of multiplication. So essentially what this is saying is if I have two different things going on and I want to know how many outcomes are there, how many different things can happen in these situations, it's always a product of the two objects put together. So looking at an example, it says John brought 4 pairs of shorts, 6 t-shirts, and 3 different color socks on his vacation. How many different outfits could he wear? Basically, the answer to this is really just you multiply all the things together, but why is kind of what I wanted to focus on in this example. And you could always think about this by drawing a diagram or trying to write out a chart of what all of the options could be. Now, the chart is not necessary to solving it, but it can help you think about why the formulas make sense. But in this case, it says he has 4 pairs of shorts. So I can kind of imagine, okay, John has these shorts of different colors, or it doesn't specify their different colors, but what we could do is when we're drawing our diagram or a little picture of our case, we can kind of imagine, okay, he's got the red pair of shorts, he's got a blue pair or a green pair of shorts, he's got a blue pair of shorts, and then he's got a yellow pair, whatever. The colors aren't important, just kind of is helping us think about what's going on. And then he brought 6 different t-shirts as well. And if I'm thinking about how many different outfits he can wear, basically the question is how many different things could he combine together? And often we use the term combination for such a thing, but the term combination is not bad. I want to talk about what that means. A mathematical combination means something often slightly different than this example, but not so different either. And I'm going to get to that. So I'm going to try to avoid using that word. But a lot of times, let's just proceed with this example. He has 6 different t-shirts, so I can then imagine, let's just number them. He could pair red shorts with t-shirt 1, or with t-shirt 2, 3, 4, 5, or 6. And basically that would be 6 unique outfits. There would also be 6 unique outfits, say if he paired the green set of shorts with any of those 6 as well. 1, 2, 3, 4, 5, 6. Same with the blue, 1, 2, 3, 4, 5, 6, and yellow, 1, 2, 3, 4, 5, 6. And you could also draw a tree diagram to try to visualize all of the combinations, but we can quite quickly see that the number of outfits he has is gonna be very large. It's gonna be a lot of them because he has so many different choices in each category. And it doesn't, another thing we would assume is, what if a yellow pair of shorts doesn't go very well with a purple shirt? Or, we're gonna ignore all sort of fashion sense for these sorts of questions because it's all about all of the possibilities, ignoring, more specific necessities towards dressing. But basically, what we can see here is he has 4 pairs of shorts, 6 pairs of shirts. If you add that up, that's 6 times 4, because each one of those, it sort of spreads out into 6 groups. And basically, it's a multiplicative effect. This is the idea of the fundamental counting principle. 4 shorts, 6 t-shirts makes a total of 24 combinations for 4 outfits that he could wear. And then if you take each of those 24 outfits and throw 3 socks into the mix, you could pair any one of those 24 with 3 pairs of socks. Again, it would multiply it again. So essentially the total number of combinations, or the total number of outfits here, again, I'm going to try to avoid using the word combination because that has a specific mathematical meaning to it, would be 4 times 6 times 3. And this would be the number of outfits that John could wear on his vacation, which 24 times 3 is 72. And that's kind of the idea of the fundamental counting principle, which is a very important idea to probability, statistics, games of chance like card games or dice games or whatever. Almost always involve multiplication for this specific reason, that if you have an outcome, a lot of different outcomes, like I like to use the example Yahtzee a lot because you're rolling 5 dice. Each one has a different potential outcome based on what you roll. And the chances of things happening is very multiplicative because, anyways, it's often due to this basic reason. So in the next video, I'm going to talk about permutations. It's a very specific type of counting, which is similar to that of a combination, and then want to focus on those formulas. But it all kind of comes back to this principle.